Okay, today we're going to look at how to evaluate trig functions using a point on the terminal side of an acute angle, but this point does not lie in the unit circle this time. So go ahead and get your notes out and we'll get going. Remember, during the video, if you fall behind in your note taking or didn't quite understand something, pause the video to get caught back up or rewind the video to listen to that piece again. Sometimes it takes a couple times through to understand the concept. All right, let's go ahead and get going. Our first example will be this point -3, 4. So go ahead and copy this down in your notes. Let -3, 4 be a point on the terminal side of theta. And we want to find sine, cosine, and tangent. All right, so the first step is we're going to have to create a triangle, just like we used when we built our unit circle. So let's go ahead and plot this point. So we have, let's see, this is -1, 2, so I'm heading 3 to the negative direction. I'm going to go ahead and head 4 up in the positive direction. There's our point. This point is, again, -3, 4. So step number 1 is plot the point. Now this point is on the terminal side of theta. That means it's on an angle, so I'm going to go ahead and create my angle. So I'm going to say my angle is in standard position. So I'm going to draw down to the origin and get a visual representation of what this looks like. Alright, so this is the angle we want to evaluate. Now just like with a unit circle, we're going to do it using triangles. So the first thing I'm going to do is go back to the point and draw an altitude down and form a right triangle. So I draw an altitude down to the x-axis. I now created my right triangle. I'm next going to use my coordinates to find the lengths of each side. Now I know this has a distance of 3, even though it's to the negative direction, it is a distance of 3, so I'm going to keep it positive just for the fact it is a distance. And I'm going to go 4 up. And now I have the two sides of my triangle. And our next step is to find the length of the hypotenuse of the triangle, and I'm going to use Pythagorean theorem for that. So I'm going to take my sides and go ahead and say this is 3 squared plus 4 squared is equal to my hypotenuse I'm going to label as r. R squared. So we quickly solve this. That's 9/16 is equal to r squared, and 9 plus 16 is 25. And now I can say that if r squared is 25, that means r will be the square root of 25, which is plus or minus 5. Now since we're talking about a distance, we're going to go ahead and use the positive root only, which is 5. So in this case, I can see that my x-coordinate is -3. My y-coordinate is positive 4. And I want to make note that even though we used a positive 3 in the Pythagorean theorem, because again it's a side length and it is a positive distance, that our x-coordinate is negative because that is in the negative direction. So make note of that in your notes. And we're going to call our r in this case 5. Alright, so step number 1 is to plot the point, draw the triangle, and find the side lengths. Alright, step number 2 is to find or evaluate sine, cosine, and tangent. So we're going to have to use our definitions of sine, cosine, and tangent. And if we remember correctly, sine is x over r. Back that up, sine is y over r, y over r. So I'm going to start with my sine. The sine of this angle will be y over r. And y is 4, r is 5. And there's our sine evaluated at this angle, 4 over 5. Our cosine is x over r, so cosine of theta would be our x-coordinate over our r, which would be -3 over 5. And lastly, tangent of our angle theta is y over x In this case, we have our y as 4 and our x as negative 3. Okay, so that's how we evaluate sine, cosine, and tangent from a point on the terminal side that is not on the unit circle. And remember, we have sine, cosine, and tangent. We can also find secant, cosecant, and cotangent using our x, y, and r. Now, if you have any more questions, make sure you write them down and we'll answer them in class. Thank you.